Alright, maybe make sure this is recording. Heck yeah, it's recording. Okay, so we're going to do rational exponents. Boom, rational exponents. This is 7-4 in your book. I tried to find the exact book online using my handy dandy little, cyber skills, but I'm not sure if I found the exact book, but I'm going to try to explain this in the best way I can. I don't know if you want me to go over properties, so I'm going to go over those too, just because I feel like those are really well to know, like you need to know them to figure everything out. But looking in this, we have radical forms, we have exponent forms, and you're like switching things back and forth. So if I have 25, let's just get right into it. If I have 25 and I need the square root of 25, how am I going to write that in radical or exponent form? This is radical form right now. Exponent form is going to be 25 1/2. And you're probably wondering, well, why? Why does it look like that? Why is the exponent a fraction? Why is it that? Well, an exponent as a fraction tells us that we're going to get a root. And the root is our denominator. It tells us what it is. So this is our square root, as you can see. Now, if we wanted a different one, for instance, we want 27 1/3. And you're probably wondering, well, how would we write that? So we have a fraction. Obviously, it's telling us that this is going to be root. And the denominator is telling us what our root is. So this is a cubed root because of the denominator. 27 cube root, which I'm pretty sure is like 3. And then we have another one, 16. All right, this denominator is telling us what our root is. So our root is going to be 4. So 4, that's how you write that. And if we were given the opposite, we can look at this and say, well, this is going to be our denominator. This is going to be our number. So we'd have 32 1/5, if that makes sense. So there's that for you. Properties. Properties are fun. If you remember logs, sorry for the background noise right now. If you remember logs, it's kind of like that. So we have our addition property, which kind of looks like multiplication, right? So what this is saying is that we have our same numbers, same base, basically. And when we're multiplying them together, we're just going to add the exponents. So this has 8 1/3 times 8 2/3 because fractions are cool. And we're just going to add these. Just going to add these. So what you're going to get is you're going to get 3 over 3, which is just going to be 8 to the 1. So our answer is just going to be 8. Correct, right? So there's that property. We have A, M. That's in a nice little parenthesis. It's all snuggled up. We have A, M, N. All right. So we see that. What this means is that we're just going to multiply these two, but we're not going to multiply the exponent to the A because that's not what we're going for here. We're just going to multiply. Multiply, because there's only one thing, and that's the A. So what this looks like is 5 1/2 to the 4th. Now what this looks like, we're just going to multiply these two. These two, we're not going to mess with the 5, really. Times 4 over 1. Now, we're not going to make the denominator the same because we're not adding fractions. We're just multiplying them. So we're just going to cancel. This is going to be 5 squared, and you're just going to get 25. So that's your answer. That's kind of how you solve that one. We got AB. M equals AM times BM. You're probably wondering, well, why can't I just, boom, boom. These are two different bases. So that's why we're going to, take the separate route here. That's why these are separate. Because these are different numbers. And if I'm writing this as an example, it would be like this. So that's what it looks like. And we're just gonna do a little almost like distributing. If you think of it as distributing, that'll help you out. So 4 times 1/2 times 5 times 1/2. Right? And then you're like, well, how do I keep going? If we remember that this is going to be rooted, because this fraction is telling us that there's a root, and our denominator says it's going to be square root. So the square root of 4 is 2. So we have 2 times 5 to the half. And you could write this as 5 to the square root. I'm not sure how she wants you to write it. If she wants you to keep it in fraction form or this expression form, but either way, it means the same thing. So that's how you do that one. Alright, next one. This one is fun. This one is the one I see people have the most trouble with. I still have trouble with it, and I am in calculus. So don't even fret. So this means this negative right here, we can't have a negative exponent. That's just not going to work. So we're going to write it almost as a reciprocal to change this to a positive, right? Like we're dividing the negative out. That's how I like to think of it as, dividing the negative out. So we have 9, negative 1/2. That's what that's going to look like. This is going to be 1, 9, and then 1/2, positive, because we divided the negative out. So what this is going to look like is this is going to look like 9 to the square root. And we know this because this is telling us that there's a root, and this is telling us that it's going to be a square root. It's a lot of practice of just recognizing that fractions mean roots and opposite. So this looks like this, and then make sure you simplify this fully. If we don't simplify this fully, it's going to be tragic because you're going to have to rationalize, and you're just going to have to do a whole bunch of extra work and risk getting the wrong answer. So make sure you know that this is just 1/3. So that's how you do that one. That one's honestly my favorite property. Then we have AM over AN. Now this one's fun too. We have same base, right? And this right here, you can almost see tells us to subtract. If you remember logs, it would be like log minus this log, and that would just be log over log. So that's how I kind of remember that, is like that. Obviously, we're not in logs right now. I don't want to confuse you, so we're just going to look at this property real quick. But if you like are good at logs and you figure out logs better, that's how I remember it, because I'm not bad at logs. It's a weird ad. Anyway, so this means subtract, right? So they use pi in the book, but I'm going to use x just because pi can be confusing. So x, 3 over 2 over x to the 1/2, right? And this is telling us to subtract, so it's going to be just 3 over 2 minus 1/2, which would be 2 over 2, which would just be 1. So this will be x to the 1, and this will just be x. Your answer is x. How fun. Next one. A over B, right? So like our multiplication one where we distributed kind of like that, it's going to be just like that. We're going to distribute. So you have A, M over B, M. That's what that equals. We're not going to subtract or anything like that, which is where that can get confusing, but just know if you have different numbers, you're not going to subtract. So we have 5 1/3 over 27 1/3. And this will look like this. So what does this look like? Well, remember, we're recognizing that fractions mean roots. So this is a root. What root is it? It's a cube root because our denominator is a 3. So this will be like this. And then remember that 27 cubed root is 3. I don't know if she wants you to leave it like this or fraction form. It all depends on what she wants, but that's how you do that property. And that's the last property. Now we're going to look into our methods of doing our fractions, our big fractions, like this. Now you're probably like, whew, hard, right? You're adding a whole nother element. But really, if you just simplify it, it's the same thing, and then you do a little bit extra, right? So we have 32. 32. And what I'm going to do first, what I've always done, I'm going to teach you, I think it's method 2 in the book, but what I've always done is I've always just looked at the denominator first. Because if we just kind of turn this to a 1, it'd be like 1/5. And what's that telling me? This is going to be the 5th root, because our denominator is 5, and fraction mean root. And so this is 2. If you want to know how to do this on your calculator, just in case you get really big numbers on your final, it would be 5, math, and then you'd go down to the one that looks like this, and then you'd put in 32. So that's how you do it on a calculator. I have a TI-84, but it should work with a TI-83 also. It's a pretty nice feature. So what we're going to get is 2. Now, we can't forget about our numerator. We got our numerator right here. Can't forget about that. So we're going to multiply that. And we're going to multiply 2 to the third. And what this is going to look like is 4, 2, 8. So our answer will be 8. Let's do another one. So we got 16. We got 5 over 4. Boom, 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 right? 5 over 4. I'm going to look at the denominator to figure out what root it is. So this is going to tell me the root. Denominator, root. What is the root? Right? What do I need to know? What is the root? The root is 4. This should be 4 square root of 16. This is actually 2 again. So we have 2. Then I'm going to take the numerator, multiply it. So we have 2, 5, 2 times 2 times 2 times 2 times 2, which is 32. That's how you do that. And if you, let's say you have a negative, like 3 over 2. What you're just going to do is you're going to do the same exact steps that we did, but it's going to look like this. Because remember, we're doing the reciprocal. So that's what this is going to look like. Go 1/5, and then you're going to take this 3 and put it right there. And it'll be 1 over 125 should be your answer. Shouldn't be a negative. That should be your answer. So I hope this helped a little bit. Hope this helped you be able to figure things out. I'll do 7, I think it was 7-7 a little bit later, just because I have to do some school stuff. But, you know, I hope this helped you and whoever else is in this class. So